The Anton marathon continues. I did a good chunk of problems in chapter 8. I think chapter 8 is going to be two videos, even if this one is a long one, just because I got to finish. And I don't want to make any more half videos. So yeah, here goes. This is part of section 8.1, all of 8.2 and 8.3, and I plan to do every single problem in chapter 8. I think it's a very important chapter for me. October 16, 74 problems, 1,453 problems so far attempted in the book, and I read sections 10.2 and sections 8.2 and 8.3. I'm reading the dates as the sections. I'm tired. I think anyone could tell that I'm tired just because I'm talking like this. All right, so for the book, I had already shown section 8.1. I was just trying to finish a few more problems. To me, this is really an important content because it's got to do with transformations, linear operators, symmetry. So I think in abstract algebra it's going to help me. I think it is. And so this is the whole business of one-to-one and onto, which is really bijections, if you think of it in analysis. And so you're trying to see whether the transformation is one-to-one or onto or both. And if it's just one-to-one, then the kernel of the transformation is the zero vector. And if it's also onto, then you get the transformation. The range of the transformation is the destination space. And the key here for this is with the same dimension. That's very important. I almost wish that they had highlighted it. Then some composition of transformations. Nothing different than you would find in functions. Going back and forth. Of course, doing more than two. How you reverse the order when you flip. When you do the inverse of T3, T2, T1, it's really T1 inverse, T2 inverse, T3 inverse. Then isomorphism, where you really combine everything. It's a linear transformation, it's one-to-one, and it's onto. Different ways in which they work for different vector spaces, inner product spaces, and then some matrix calculations. Here there's a mistake in the book. This is not minus 16, this is plus 16. It's got to be plus 16. If it's minus, it doesn't work. So that's a little typo in the book. Then the whole business of coordinate maps, which are ordered orthonormal sets. So it has to be ordered. It's a coordinate. And that was it. Yeah, that was it for the book. And then for the work itself, I finished more problems in section 8.1, and I did pretty well in the true and false. Then one of the diagrams in the book was confusing. The whole business of you get to from a smaller dimension to a larger dimension for one-to-oneness. You have to be able to map every single one. And then, and then in the case of onto, you have to be able to map back and get the complete image. You can have more, but you cannot have less. Yeah, I think I said that correctly. I think so. Yeah. Again, this is just the reading. And of course, as I always do, I work out everything in the book, and that's how I figured out that one of them was wrong, and I think I'll show it. It's later. Made a couple of mistakes in the early problems, but then got my bearings, but still every now and then I screwed something up. Yeah, just transformations, finding out if they're linear, finding out if they're onto, and one-to-one. Compositions. couple of proofs. Of course I did it. I attempted every single problem. And then for section 8.2 I only missed one true and false. Then for 8.3 the notes. And something that I've shown before is I like to show, if two theorems are very similar, I like to show them side by side, and I want to know exactly what is different between them. This is 8.32, 8.33. Yeah, here it is. Yeah, here it is. It's not minus 16. If you try minus 16, this doesn't work. You don't get this result if it's minus 16. Yeah. Then the problems in section 8.3. I got close in some cases, but in some cases I figured it out just by looking at it when I really needed to work through it. So I took an answer for 15 from the answer book, worked it through, and then when I did 16, I did work it through the same way, and when I did 17, the same. Yeah, and here I did answer it correctly. I tried to do too much. Sometimes I do too much, more than I need to. Interesting how you can take a matrix and use it as a derivative. So yeah, I knew what the derivatives were, so I knew what the outcome was, and then when I was given another vector, sure enough, I can do the derivative. Some proofs I felt strongly that I got it right. These proofs I think are a little weak. I'm not sure I got them right. Of course, there's no answers in the book for those, and I only got one wrong, true and false, for section 8.3.